Hello, and we are back. Check, check. Yeah, we're working. And we are back. I need to clean up a little. Hey, Andy is first. Welcome. Welcome back. I just got back. I was going to clean up a little. And maybe we will tackle some power supplies. I have not seen what... Oh, I know what I was going to do. I was going to pull up some links. If people want to know, like where I got those ribbon cables from. You know, the stickers. People, I'm not sure if any of the same people are going to be here for this stream. Maybe. It is PSU time. Yeah, it was a quick trip. Yeah. Hello, Albert Davis. It was cool. Yeah, they're friends and co-workers. We end up usually talking about work a fair amount. Hello, hello. Where's that box of supplies? All right. What I'm going to do, though, this is the box we're going to be opening up. Let me see if I can find where I got those ribbon cables from AliExpress. Since some people seem to be interested in that, let me get logged in and look at my orders. Okay, I'm still not logged in. Bear with me. And I'll pull up. I know I got those stickers off Amazon, so I can pull up and share a link with that. Some people were asking about. Let's see. All right, fine. I'm in my orders. Okay. What did I order? No. It's been a while. I gotta go way back in time. Ordered a lot of South bridges, a lot of HDMI connectors, various screws, switch ports, resistor books. There's those USB-C ports that I bought. I'm still looking. It's been longer than I thought it had been. Well, unless I've overlooked them. I had to have overlooked them. This is back in 2023. Well, I can't find them. Let me do a search. Oh, there they are. Okay, now I found them. Looks like I've ordered 10 pieces of it. Okay, I'm trying to get a link to it. But when I click on it, it takes me... Oh, there it goes. So what did I order? 10 pieces, 0.5 millimeter pitch, 5 centimeters long, 40 pin forward direction. Which I figured out the forward direction thing used to be important because it depends on, you know, the reinforced blue plastic piece. Either it's on the same side on both ends or on opposite sides. Let's see. Let me see if I can share something. Screen capture? No, that's a schematic. That's not it. And that is really, really zoomed in. But that's it. So if I click on this, I think it was 5 centimeter, 40 pin, forward direction. Yeah, a whole $3.18 for 10 of them. Does UART diagnosis work for the Mac? I think there's other diagnostics for the Mac. At least there used to be. Who can stare at the box at the longest? Well, I've got something else up now, Andy. So, but that's it. That's where I got them from. So if I copy that, into chat, that should get you there. Okay. And now if I, let me find the Amazon link. I'm just following up on some stuff I talked about earlier. So if some of you just joining, I mentioned giving you some links to some stuff. Orders. Where did I get those? Well, oh, here we go. I had to expand my search because it's been more than 3 months. Okay, found them. Click. All right. Copy. The labels. That link doesn't work. Let me see. There you go. All right, link works for me. There's a link to the labels. Okay. Now, where were we? Where were we? All right, let's open this box up. As soon as I find darn, I guess I'll use my X-Acto. I had a little box cutter, I can't find it. Let's see. Oh. I see a, is that a switch light? I think it's a switch light, not a Pro. I think that's an Xbox. Maybe another Xbox. And a conventional fat power supply. Let's take a look at this fat one right here. Okay. What is this? 400 FR. So this would be for the 1200s series. Any bugs in this one, I wonder? Looks like somebody's already pried it open. You can see the marks. So yeah, it's been opened up already. Roy, did you work on this one? Yeah, these were sent to me by Roy's Repairs. He's in Florida, I believe. All right. Hey, somebody stole the parts out of it. It is missing some parts. Missing the main driver MOSFETs for the 12-volt rail and the 0.1 ohm resistor. And I see a bit of a burn mark right over here. Which is probably what originally killed it, something walk across there. Not seeing, oh, the fuse is gone. You took the fuse, Roy? You took the fuse. Okay, so we're going to need some parts. I can't complain. He did send these to me for free. So we're going to need some MOSFETs, a resistor, a fuse, and that's not going to be the only problem because it was dead. I'm sure he stole these parts to fix another one, I'm guessing. Who salvages parts from a power supply? Well, somebody trying to fix another supply, I guess. What? I'm going back through some of the chat. I don't know what's going on. Chat's a mess. Okay. So, fuse. But you know there's something else wrong with this thing. So let's see if we can get the meter. Can we get the meter in the? Let's get the microscope with the meter. There you go. How's that looking? Is that showing up all right? Oh, greetings from Columbus. Well, you are very close to me then. Very close. I need diode mode. I need diode mode. Okay. A crack? A cap? Oh, I see that other. I think it's just a little bit of a fuzz or something. There, right there. Yeah, it comes right off. I'm just going to guess this controller is bad. Well, I've got something coming in today too. It's going to be kind of exciting, at least for me. I've got the hardware coming, so I can program TEA 2016s or TEA 2017s. This controller chip. I'm going to be trying to. the 2016 works pretty good to replace this chip. It's not perfect. You don't quite get as much current. You start going over like, I can't remember, 26 amps or something, and it gets a little unstable. The PFC boost voltage starts wandering around and it gets unstable. So I'm going to see if I can program some TEA 2016s to be a little bit better replacement. I ordered that from Mauser. It's supposed to be out for delivery today. So that's going to be some fun stuff. I got a computer set up for it. Where is, I'm trying to find my, I have not discharged this thing because I'm assuming it's pretty dead because it's been riding around. It's been here for a month. All right, pin 1. 0.7. 2, 0.57, 3, 4 is ground. 5, 6, 7 is no connect. 8 looks good. I guess I could. Oh, 9 is. Oh, 9 is open because the MOSFETs are not there. You normally would read through like the gate circuit or something for the MOSFET, and it's just not there. So that's why 9 is open. 10, 11, 11. 15, 16. All right, I don't see any blatant shorts. It could still be bad though. So I guess the thing to do is to put some MOSFETs in this and a fuse. See what works, see what doesn't work. I'm assuming it won't work. Oh, that pad's about lifted off there. Have to be careful with that. And I did see, I'll show you, I did see a burn mark earlier in another part of the circuit that I'm going to guess is what originally killed this one. It doesn't want to come off of there. Where is my tweezers? There's just some flux and junk from where the MOSFETs were removed. All right, now there's the fusible resistor was removed there. 0.1 ohm. All right, I know I saw right in there is what I was talking about. See that mark there? So something stepped right there, and that is 400 volts right there. 395. Oh yeah, okay, that's the burn mark I saw. I thought it was that little tiny thing there, but no, that's the burn mark I saw. So yeah, it doesn't look very good. I'm going to imagine the DAP053 is dead. I do want to get this carbon track out of here though. You can see where that's jumped between those. Yeah, it arced between there. Well, something stepped there and caused it. There's one of your temperature sensors, NTC41. Current sensors for the, they are in the source circuit of the PFC MOSFET. That's how I can sense the current that's being drawn. The PFC MOSFET is in here, I think. Yeah. Right there's your PFC MOSFET, and there's the diode. So let me find a couple of MOSFETs in a drawer right here. Got MOSFETs. Excuse me. And resistor, and an excuse me, an 8 amp fuse, which I need to order some more 8 amp fuses, looks like. Okay. What are we talking about? I did have a nice lunch there. Worms, I did, thank you. Booter was here? Where's Booter? I see NanoFix. Hello, hello. Oh, there's Booter. Booter, I'm excited about your new shop. I really want to see that. I'm excited about that for you. Hey, JFix. You know, Booter's getting a new workspace. I think it's after the first year. Well, it's always fun. You get a chance to, you know, redo things maybe like you would like to have done the first time you set up a shop or something, you know. Let me clean that top of this. There's a little bit of gunk in there. I don't know what that's from. I just like for it to be nice and clean. Don't know what this is from, if this is from the removal or just the past roach activity. Okay, anything else missing? Oh, yeah. Both of our filter caps are puffed up there. You see that? Yeah, both of them are swollen. If these things swell, that tells you that the PFC went wild, and it will generate 600 volts, and these caps will blow. Doesn't look like they totally blew their guts out, but they're all, the dome is popped up on both of them. So those will have to go. Yeah, before I fire this thing off, I may take them off and check them. I bet you they're good right now, but I would not trust that. Yeah, I would not trust that for anything long term. All right. MOSFET. And a MOSFET. Come on, stop. Oh, don't fall out. Trying to get them their length about the same. Something like that. Come on, straighten up for me a little. All right. And our 0.1 ohm resistor, R9. And we need a fuse. Should probably check that bridge rectifier, but those things they're rather tough. And this was not lightning damage, this is bug damage, so I doubt the bridge is damaged at all. They are rather tough though. All right, so that stuff is replaced. Ooh. I was looking at these capacitors. I need to change them. I was debating whether to fire it up first. I don't think it's going to run anyway. Look at that one. It has spewed its guts out. Now the other one has not, but it is domed. So yeah, it is what it is. Like a, what, a Brian? I'm sorry, I'm just, who's Peter? Brian or Roger. No. Okay. All right, those are changed, but she's not. I need to. All right, capacitor. I need to. Let me get some hot glue. Get my old hot glue gun warming up here. And I think I may just replace that DAP 053. Because what I don't want to do is replace these capacitors with brand new ones and then have them blow up because it's putting 600 volts across them. Which I think I'd figure that out before it blew them up and, turned it off. I like to think, anyway. Capacitors. Yep. Yeah, they don't do that on their own. Not on their own. Where's my screwdriver? Ah. Come on. Go. I hope this transformer is still good, because I have had one of these capacitors blow out, and when they vent, they tend to blow right into the side of this transformer, and I had it run one time. It took me a while to figure out why the thing wouldn't run. It would try to start and then shut off. Bad transformer. See if I can get this out of here. We're going to have quite the investment in this power supply. Electrolyte leaked out of that thing. Yeah, putting all these parts in it. Is this power supply worth repairing? Probably not, but I'm going to do it anyway, because I'm weird that way. Now this one still has some weight to it. That one doesn't feel empty. Anyway, I don't trust them. Not enough to put 400 volts across them anyway. But I am wondering if that controller is bad, because for some reason it decided to run too much voltage across these things. I have seen 600 volts on one that was just running away. If if the chip is bad, or if the feedback resistors, have gotten damaged, really all it has to go on is that feedback resistors. The chip is looking, by the chip I mean that controller, it's trying to maintain 2.5 volts on pin 2. And that 2.5 volts is basically divided down. You've got two 7.5 meg resistors, and on this model I can't remember if it has the 750K or if it just has that, and there's 100K to ground. So it's just a divider chain, and if you do the math on it, it works out perfectly well. You'll get 395 volts. When you have 395 out, there'll be 2.5 sitting on that pin, that feedback pin of that chip. And nope, not going to do that. Not going to put that thing in backwards. The leads are already bent that way. Yeah, I've done that before. Yes, I have put one in backwards before. Not today. Not today. These are Kemet capacitors. I mean, I get them from Mauser. That's the same way. Yeah, that's bent the wrong way. Should probably do one of these at a time. So what I'm going to do is put a little hot glue in there for this to sit on. Push that down into place. Let it cool a little. Stay there. Hot glue is always such a mess. Okay. You still know parts? Oh, Roy, somebody, yeah, somebody had taken. So I wonder how you ended up with it, Roy. Did somebody stick it in a chassis that they sent you? Because it's definitely been worked on. It's got a lot of parts missing. It was somebody's parts donor. All right. I'm double checking those capacitors are in there properly. Don't want to do that. Don't want to mess that up. So I didn't see any shorts on this chip when I was when I was checking it earlier. I just don't trust it though. Let me look at this board again. Okay. Because if that chip is good, it would have to be something to do with these resistors here. And you can see, you know, there's been an arc in that area. That's your divider. 7.5 meg, 7.5 meg in series. You come right over here, you go into that. You come right through here and you split. One goes down to a MOSFET on down here. The other one comes around to this Zener. And this is a, That's the wrong one. I'm sorry. Yeah, there's the Zener. That's not the right. This one, 95C, which is actually, yeah, it works out to be about 95K actually, but. And so there's where that sample goes in on pin 2. So in theory, we should have about a reading of like of like 9500K. Let's see what we have. On pin 2. Yeah, 94.7K. Okay. And the other place it goes, that voltage goes, is right down, if I can follow it. It's going down to Q34 right here. And it can break down sometimes. Board is dirty. So what do we think? Do we try it with that chip that's in there? I'll do it. I don't want to blow up my caps, but I mean, I'm going to be, when I test it, I'm going to be monitoring that voltage anyway. I see it go beyond, 400 volts, and I'm yanking the plug on it in a hurry. There's some flux left behind where somebody removed the, I'll have to heat that up, get that off there, where they removed those things. Let's see. Just look and see if anything else was knocked off when they removed it. No. Let me do a quick check again in diode mode on this chip. But I don't think I had any shorts there at all. Let's see. Let me get the, where's my meter? Where's my meter? Good. Guess I could turn off that beep. It won't let me turn it off there. It's pin 10. That looks, yeah, this all looks good. It's not shorted. Doesn't mean it works, but it's not shorted. And let me go back to the, let's go back to the overhead. No. Make sure I don't have a short on the input, on the AC input, but I don't think so. So like right across here. No, no short. Here's that bridge. Yeah, I'm not in diode, but I'm just in continuity mode looking for a short. There's no short there. All right. We'll give it some voltage and see what happens. Let me get my load set up here. Positive, negative. Let's see. on so you can at least see it. Okay. Let me get my meter. Set up. I'm going to monitor the voltage across these caps right here. And that's really the main thing we need. Dial the voltage down. Okay. Watch this voltage start coming up. Well, let's hook the power to the... I knew that wasn't coming up. Something's not right. Sorry, my arm's going to be right in the way. So we'll check. Nope, no current draw to speak of. Okay. Watch this voltage. Hey, she came up. Yeah, 394, 393. Drawing 5 amps of current. What do we have right on the output terminals? I'm going to say right at 12 volts. 11,971. I think she's fixed. We'll give it a good, a good check out at a higher load. Well, that was easy. So I don't know if somebody stole parts off this to fix another one, or if they just took those off in the process of fixing it. I don't know. Is that a light on? Light? Are we at 150 on the caps? We're at 395 volts on the caps with it running. If the PFC wasn't running, you'd have about 170. Whatever you get when you rectify 120 volts and filter it. All right, that's working. Let's give it more of a load. That was at 5 amps. It needs to be able to do 31. All right, we're stable here. Let me see if I can somehow get this meter worked in here. Get down in there and measure the 12 volts. All right, let's crank up this current. 10. Still stable. 15. 20 amps. Ooh. No. That was getting unstable. Let me ease it back up. We're at 15 amps right now. 16. I'm watching this boost voltage here. 18. 19. No. 20. Oh, we're running all over the place now. 24 amps. Look at that hitting 412. That's wandering around a lot. 31. I don't like that. 415 at 31 amps. I don't like that. That concerns me. We're back down to 5 amps now. I think I'm going to swap out that controller. Don't like to see it wandering around that much. Don't like to see that wandering around that much. It is, it didn't really run away, but that voltage got awfully unstable. Not the output voltage, but the voltage across that capacitor. The PFC boosted voltage. So these caps are going to be hot. We are going to discharge them before we handle anything. Okay. Yeah, I'm going to change out that DAP053 and give that another try. I do have some original DAP053s. That's what I will use. Because, I mean, usually, yeah, this thing should be able to put out 12 volts, 31 amps, and be just rock solid. That PFC voltage not wandering around like that. All right, I'm going to give this 350 C air. Ooh, now I can smell roach nastiness. You start heating it up, it'll come at you. Maybe add a little solder to this. I need to get rid of those glue dots. Give me a second. They keep the chip from sitting down flat sometimes. Didn't get rid of all of it, but I hope I knocked enough off. We'll sit down there right, maybe. Should probably not install it upside down. Not this time, maybe. All right. Can I get some flux out from under this thing? Yeah, the whole board could use a good cleaning. Get the roach mess off of it. Okay. I think she's down. Does she work any better, though? That's the question. Where does all the current go? It goes into this load here. This load, which is using MOSFETs basically, is having to dissipate. There's a fan, internal fan in it too. It will dissipate that power into the form of heat. Okay, we got that. I can't use the variable transformer for this. Too much current. 13. She's already charged back up to 13.9 volts. A little absorption into that dielectric. All right, there we go. We're at 5 amps. Yeah, let's fire it off. And we're back running again. 5 amps, roughly 60 watts. 394.7, 395. That's about what it should run. So let me make sure that's in the picture. All right, what I want to see is don't drop my tweezers. That's not tweezers. I want to see that stay stable at those higher current ratings. That's what I want to see happen. Oops. Come on, get in there. 11.95, 395 volts. Let's wind it up. I'll turn my fan on to be blowing on it just a little. Ten amps. $15 amps. That's still wandering around some. I don't like that. What is going on with that? Don't like that. Nope, nope, nope. Look at that. 417 volts. We're at 17 amps of current. Nope, 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 nope. I don't like that. This one's going to be a pain. Let's discharge it. Guess you can't really see the discharger, can you? Okay. We're discharged. What is going on with this one? Do we have something removed? Microscope. There's not much to this circuit. I should probably clean that flux around those resistors right there. That doesn't look too good. I do have these resistors. They're relatively expensive though. They're 7.5 meg. I use 0.1% tolerance. The other thing that's on the circuit that I could remove is Q34 there. It's not necessary for testing. It's part of the shutdown circuit. Still got a mess of flux over there to clean up. But this right here, We've got that resistor right there. And there's a capacitor to ground right there. And a zener. And roach poop in random places. These resistors look just fine though. I don't see, sometimes you'll see a little mark on the top of them where they've been damaged. They look beautiful. I doubt the zener has failed. I'm going to remove Q34 because that's where it, I'll show you, it's on that same circuit. Yeah, right here, lands down here, the drain of this MOSFET. Just a 2N7002, nothing special really. But this is driven by a opto-isolator, and can tell the thing to shut down. If you remove it, it can't shut down. But all right, broken too. So was it damaged, or did I just break it? I don't know. How about this? How about we replace it? Because I don't know if I broke it or if it already had a hairline crack in it. I really don't. I don't know for sure. That was a 704. 704. Do I have some? I only have 100. I don't have 100 left. I've used quite a few of these. Looks like I actually ordered 45 for some reason. I'm guessing that's all they had at the time, Mauser. I think I bought all they had. Yes, they're right about there. Beautiful, beautiful. It's still going to move as soon as I put some solder on that leg. If I don't hold it down. All right. Clean that up a little. Who else is streaming today? Anybody else streaming? All right, we replaced that. Doesn't make any difference whatsoever. Oops. I'm still set for 5 amps. Okay. What are we doing now? 391. Oh, well, probably will hook the load up. I forgot that I took the load loose. Maybe a slight spark here when I go to discharge these caps. Yeah, I brought it up with no load. 7 volts and dropping. All right. $395. All right, what's it gonna do this time? 10 amps. I should probably be metering my output, I suppose. No, it's still unstable. $30 amps, 31. Rock solid right there. Well, and 414 volts there at 16 amps, bouncing around. Very strange. Unless this meter is lying to me, which I kind of doubt. I really doubt. Nope, she's not lying to me. She's not lying to me. Discharge this. So what is going on with this? There's not much to that circuit. It was slightly more stable. Only slightly. The Zener. The output doesn't seem to be changing, the 12-volt output. So in theory, the load shouldn't be shifting around, making it do that. Because it will, I mean, like when I brought it up earlier with no load on it, the PFC will overshoot and then come back down, eventually settle down. But a change in load could make it do that. It can make it, you know, overshoot, undershoot a little. But I was giving it a rather gradual change in load. I'm just looking at where that arc was. It's in the area of the PFC. There's the PFC MOSFET right there. Could there be something damaged? That's mostly working, but not 100% working. Current sense resistors look okay. They don't look to be damaged. We replaced these capacitors. There shouldn't be anything on that side of the board. So that is basically ground right there. That is your common ground. That's what's tied to the negative side of your capacitors. So that's ground. And what is this? Where it arced. That's a jumper. To the positive side. Okay. So that's effectively right across that 400 volts. Yeah. There's the positive side of your capacitor, jumper. This right here. And what is that? That's another jumper coming over here. Okay. So I don't really think I was just curious if there was some component hooked to this area. You know, but anything in this area should be used to getting 400 volts. It's not like 400 volts went to something that's supposed to get 16 or something. It's 400 volts went to ground, basically. Caused that arc right there. And why does YouTube notify me that I'm live streaming? I don't get that. I don't know. This is going to be a time-consuming one, I can tell. Because it works. 99% works anyway. Those resistors look perfect. I was looking for anything else on the board in that area. Any kind of residue of some kind. I could change those resistors out. But there. Zener, resistor, capacitor, right into pin 2. I mean, that's all there is for the PFC sense. That's all there is. There's no more to it. It's totally out of focus. Heat it up. Let's see. Trying to think if there's anything else. I'm just looking at this PFC coil. Yuck. But she's not broke loose from the board. Hope it's not because of roach contamination. I might give the board a good cleaning. Changed out the 704 down here. I don't believe it's at Zener. Those just don't fail unless something crawls across this right here and bypasses these. Then you end up with 400 volts coming over here, which should only be like 2.5 volts. Then all bets are off. Whatever happens, happens at that point. Trying to think if I've seen this before. And it sounds familiar, but I don't remember if I was able to fix it or not. Because I don't believe that's normal behavior. I may just get another, unless I haven't noticed it, I don't think that's normal at all. Let me grab another. There's something changing my test setup. Let me grab another identical 400 FR. And we'll put it through that same test. Do I have one? No, that's an ER. Let me find another 400 FR. Now that's an FRAAB. All right, here's an FRAAA. Slight revision differences, I suppose. Here's another. Already been repaired. I did not snap it back together because I was probably, I'll do that when I want to come back and make comparisons to one. All right, here's another FRAAA. We'll hook it up the same way and give it the same load. And see what happens. We're at 5 amps. $3.95. All right. $10 amps. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31 amps. Pretty darn rock solid, I would say. Holding about 395 no matter what load I give it. You can see if it fluctuates a volt or so. She's not shooting to 415. This other one, right, was around 16 amps. It didn't like it, did it? It would be stable up to about 16 amps and then start wandering around all over the place. There's 15, 16, 17, 18, 19, 20. No. She's rather solid. Rather solid. Yeah, I can take some diode measurements. I've got them recorded. I have a feeling this is going to be a little more subtle than that. But we do have a working one sitting right here. That's why this one has been used for comparison, because I notice it's got a check mark on the other side. And that's what I put on there when I'm using it as a reference one that I trust. I'll put that check mark on there so I don't get confused when I have two boards laying out. Let's discharge this. All right, that is rather discharged. So here's our known good working one with the check mark. Here's our bad one. Now I'm going to short these capacitors out. Let me make sure this thing is... I like to get as much voltage off these caps as I can, just because it skews your reading. I'm draining these things well. All right. What time is it? It can't be right. There we go. So take a couple of clip leads here. At least one. I'm going to connect the two grounds. Like so. So I can just go, excuse me. So I can just go straight back and forth between them. Like pin 1, 707, 708, pin 2, 549, 583. That's a difference. Make a note of that. And that is the PFC sense circuit. 549. All right, pin 3. Make a note of that. I hadn't forgotten. It looks pretty darn close, doesn't it? Pin 4 is ground. We'll skip that one. Pin 5. 660. Pretty darn close, isn't it? 6. 650. 649. 7 is no connection. 8. 1.48. 1.47. That's pretty darn close. 9. Yeah, that's going to be a different reading there. There's something that gets latched sometimes on these things. That's a bit of a red herring. That'll change here in a minute. There it goes. See? I touched this other pin. There's something getting latched up in here when I'm probing it. Now it'll read normal. 1.13. 1.17. 1.13. 527. That's different. 484 and 527. That's pin 11. That is pin 11. Make a note of that. That's different. But also keep in mind, 11, if I'm not mistaken. What is 11? It's connecting to these output. I've changed out these MOSFETs, these driver MOSFETs here. So they're not the exact same as this one. This one has the original ones on there. So could be a slight difference in reading there because I've changed the MOSFETs. They're not identical anymore. 9, 10, 11, 12, no connection. 13, 707. 704, that's fine. This is 14, 627, 14, yeah, 618. 15, 704, 15 here, 702, 16, 16. Pretty close. Let me go to resistance mode. What do I have on pin 2 here? 103K. And here, 95K. All right, let me make sure my caps haven't charged back up a little, because it will skew this reading. Now, what do I have on pin 2? 95K, yeah. As those caps kind of charge back up, it'll mess up. 95K, 94.7. Slight difference there, but so I try to short these things out really well, because there's just a few volts sitting on these caps is enough to mess up some of these readings. 95K, 94.65. And that diode reading, though, was different, though. 548, 582. Well, there is a zener on the circuit, and there's a capacitor, and a 95K ohm resistor, which is what you're reading. 95K ohm to ground. 582. Which is odd to me, because these boards, except for the MOSFETs being changed out, should be identical. They're both AAA revisions. They should be the same. Bad zener? Zener breaking down? All right, we'll remove the zener. I do have them. Pin 2. It's definitely slightly different. What do I have? What's a normal diode reading on pin 2? Looks like about 556. What are we talking about? That multimeter? Yeah, I've changed the DAP053. It could be bad. But if it's bad, it's bad in the exact same way as the previous one. It was just not very likely. Yeah, all right, I'm going to remove that zener. Because why not at this point? It is, what's the value? It's a ZD. What is that zener? 8.2 volts, I believe is what it is. Oops. Let's see, how do I want to do this? I have been known just to do it this way. I broke the leg off of it, so I'll be changing that now. It was ZD, or ZD if you prefer. And I do have those. I'm going to change it. And see, tell you what, while that thing is off, what is the diode reading right now with the Zener removed? On pin 2, 581. And what was the other one over here? I think it was 5. It was lower, 5.4 something. Yeah. I don't think that Zener's the issue. Just don't think it's the issue, but we're committed at this point to changing it. Oh, come on. Excuse me. All right, Zener is in there, and I think she's still going to read the same. On pin 2, 584. So no change in the reading. So we got the 2 resistors, Zener, resistor to ground here, 95.3 k ohms, and we have a capacitor on pin 2. That's just all there is to that feedback. All right, I'll give it a try. I don't think that's going to do anything. Let me try. Shorten those out again. Resistance to ground, 94.65. 95.1. Slight difference, not a huge difference. All right, you get that out of the way. Starting to get parts stacked up everywhere. Put those away later on. Okay, we're set. I need my meter. Oh, come on. Clip on there. There we go. 'Kay. We're running. Ten amps. 11, 12, 13, 14. Nope. 15, 16. Yeah. We're bumping into the 415 volt range again, around 16 amps. Thirty-one amps. Yeah, she's running 416, 417. 20 amps. She's bumping up there too. 16. There's 17 amps. Very unhappy at 17 amps. Turn the load off. And she's holding at 419, 420 volts with no load. Why are you doing that? Oh, it's slowly going to drift down now. Load on. Off. It's like getting, well, the load's off right now. Load on. There we go. That's at 12. Very unhappy. I don't know if I think about this one. But I think I've seen this before, but I can't remember. I cannot remember. I wouldn't think it's a divider issue because it's stable, you know what I'm saying, under some loads. You know what I'm saying? The way those resistors divide isn't going to change. It's probably it may be something unrelated to the PFC circuit. And the PFC circuit is just responding to it. Does seem like I've seen this once before, but I cannot remember. And yes, she is still hot. She's not plugged in, but she's still got 400 volts across there. Well, 250 when you unplug it. No, I had 300 and something. Hope it's not like something like a bad transformer, a bad coil. Because that could show up in some weird ways. Very weird ways. I don't know, guys. We're going to have to think on this one. I've changed so much of the PFC circuit. Not the coil, of course. And this is one of those odd ones. It doesn't just absolutely fail. It does weird stuff. Very, very weird. Oh, well, it's been 2 hours. I'll figure it out, yeah. I have not changed the optocouplers. They are the originals. They are the originals. Have not done anything on the cold side of the board at all. Changed those driver MOSFETs. Replaced those capacitors because they had blown the ends out, which means that PFC voltage had ran away at some point. Which PWM do you mean, though? I mean, there's rarely a PWM for the PFC, and there's one for the 12-volt circuit, where it drives those. Maybe. I hate scoping these supplies unless I have to. It's just dangerous. You can do it, and I've got a 10-to-1 probe, and I've got an isolation transformer. I can do it. Still makes me nervous to start probing 400 volts. Particularly when you start probing the gates of some of this stuff, I don't have a battery operated scope. Yeah, it gets dangerous though. You start adding capacitance from your scope probe into the circuit on the gates. I don't have a portable scope. I've got an old Fluke somewhere that doesn't work anymore, but I keep meaning to buy a battery operated one. Just haven't, convinced myself I needed one yet. Now I don't have any differential probes. Like I said, I do, when I am testing, I do isolate. This power supply is isolated by that transfer. Well, in this case, I'm plugged into the mains that wouldn't be isolated, which is kind of a problem. I have to plug back into the isolation transformer, and I really can't run it at 16 amps there, I don't think. It'd be pushing it. I'd blow the fuse in that isolation transformer. So this is where I need this is my excuse to buy a battery-powered scope. Okay, well, I'm not going to give up. I'm going to take a break, though. I'm not going to give up on it totally. But anyway, if I figure it out, I will definitely let you know. $100. That must be for the differential probe, not for the scope. I am going to take a break. And try to relax a little. Later, guys. We'll do it again soon, I promise. Thanks, Andy, Russ, Worms. Hey, NanoFix, there's Roy. Thanks for coming by and hanging out with me for a while. We'll have to do it again. See ya.